In this problem, we want to synthesize this meta-disubstituted benzene. And what we note here is that we have this bromine, which we can install through a bromination. But we have this carbon-carbon bond, and we normally install those through a Friedel-Crafts alkylation or acylation. But one thing to keep in mind here is that this carbon is sp2 hybridized, and we can't do a Friedel-Crafts using an sp2 carbon chloride. So we need to sort of have a workaround here. And what we can do in this case, if we think about our chemistry and we do this retrosynthetically, we can make this using a benzylic bromination. Okay, then from there, we'll be able to install this alkyl group through a Friedel-Crafts reaction. And then this bromine just through a standard bromination. Okay, but one other thing to think about in terms of this problem is the fact that this alkyl group and this bromine are meta to one another. But we know the bromine and alkyl are both ortho-para-directors. So we have to sort of come up with a workaround to get these installed meta to one another. And the way we can do this is instead of installing this alkyl group through just a Friedel-Crafts alkylation, we can do it through an acylation. And remember, the acyl group is a meta-director, so that will allow us to work around our problem. So to start out, we'll start with just a basic benzene ring. And the first thing I'm going to do is install these two carbons through a Friedel-Crafts acylation. So I need the acyl chloride, and I need two carbons. So now I have that group in there, and I also have this acyl group, which we know is a meta-director. So this is a good place to go ahead and install our bromine atom. So we'll use bromine and iron tribromide. Since this is a meta-director, it will direct it to the meta position. Okay, so now we're left with this acyl group, and we need to do some transformations to get this converted to this benzylic bromide and then to the alkene. So in order to put the bromine at this position, we need an alkyl group. So the first thing I'm going to do here is reduce this carbonyl down to a CH2 group. For this one, let's use a Clemmensen reduction, which is zinc amalgam and HCl. So now I've reduced that to the ethyl group. From here we can do the benzylic bromination, and that will work as long as we have hydrogen at this position, which we do. So for this, let's use NBS and light. Okay, and then finally we have this benzylic bromide, and we can just do an elimination reaction, which you should remember from Organic 1. Let's use just a bulky tert butoxide base. There's a variety of bases you can use, but essentially we have our base, and this will just do an elimination step to give us the alkene on the ring. And that takes us to our final compound.